So good afternoon to all. Yes,
Good afternoon, sir.
Good
very
afternoon,
good,
sir.
very good, very good. Others, can you respond? Other students, good
Good
afternoon.
afternoon. Good
Good
afternoon.
afternoon, sir.
Good afternoon,
Good
sir.
afternoon, sir.
Good
Good
afternoon, sir.
afternoon, sir.
Very good, very good. Yes, very good. Everybody completed the first two experiments. I hope all of you completed the first two experiments. And did you upload first two experiments in Google Classroom? So any doubt for first two experiment? Any doubts? Any queries? Any doubts? Just open your mouth and ask me. Any doubts? No doubts. I think it's clear all doubts and also how to calculate coefficient of discharge, toxic friction factor. Yes or no? So can you open your mouth? It would be better. Anyone? Yes,
No, sir, no doubts.
no doubts. Very good. Thank you. And directly we'll move on to third experiment, Orifice meter. So before going to start this Orifice meter, just you should know like basic fundamentals of Orifice meter. Okay, just basic fundamentals of Orifice meter. And also, first two class we learned about Venturi meter and toxic friction factor. We'll move on to this orifice meter. What do you call? This orifice meter also used for measuring the volumetric flow rate of the fluid based on the two equations which can be used for both orifice meter and venturi meter. So these basics anyhow we are going to learn about in fluid mechanics theory. Just I want to tell both orifice and venturi meters are used for measuring the volumetric flow rate of the fluid that is based on the continuity equations and Bernoulli's equations. Okay, continuity equation and Bernoulli's equations. It is used for to measure the volumetric flow rate of the fluid. And also already we learned about venturi meter, how to take readings and how to find out calculations related to actual discharge, coefficient of discharge, theoretical discharge, velocity, all those things. So with the help of venturi meter, today we are going to learn about orifice meter, how to take the readings, and followed by just I will show that some other visual lab reading for orifice meter also, just for understanding. Okay, just for understanding how to do that orifice meter, and also I will show the video we have taken from what I call fluid mechanics lab in what I call is already I allowed all the students. So we have taken some videos from fluid mechanics lab physically. That also I can show from what I call through this Google Meet. After showing that video, I can explain each and every terms, what is the uses, and then you can take the readings and do the calculations. Any doubts? So any doubts in the first step, you can ask me, we will explain once again. Any doubts? No doubts?
No,
You
sir.
can respond so that we can start. If you have any doubt, we can clarify or we can give a what you call idea also. Any doubts? No. Yeah.
No, sir.
Right. Here, just I'm going to share this screen. I think you can able to see the screen. Yes. Everyone visible this presentation? Yes or no?
Yes, sir.
Yes,
Yeah.
sir.
Yeah, fine. And directly I move on to this third experiment, calibration of orifice meter. It is similar to Venturi meter only. It is similar to Venturi meter. The main objective of this orifice meter, calibrate the given orifice meter for flow measurement in the pipe. Okay, so you have to measure the flow measurement with respect to different what you call flow condition and also based on the different diameters. And the equipments normally all the what do you call experiment which is used for experimental setup, orifice meter, stopwatch, measuring scale, and others if needed. Any other equipments. And then third one, I mean second slide, already what do you call, we discussed about what I mean by density meter, orifice meter. So both it can be useful for the flow measure like mass or volumetric flow rate. So through what I call, or we have to find out velocity of the flowing fluid. So flowing. And the next, the main difference you should know what do you mean by venturi meter and orifice meter. What do you mean by venturi meter and orifice meter? You should know the main difference. So if you look at this image, okay, if you look at this image, in this venturi meter, it consists of three parts. One is converging, and next one is diverging, and third one is throat section. So section 1 and section 2, let us assume this is a pipe. So any fluid or liquid or whatever may be entered to the inlet and leaving to the outlet. We have to find out what they call flow rate or discharge, any other things. So, like you look at the top, there are three parts in venturi meter. It consists of converging section, throat, and diverging section. Whereas orifice meter, so like that is called as orifice meter consists of a thin plate. Okay, a thin plate or a board. It may be attached to the experimental setup. So for here also we have to find what the volumetric flow rate of the fluid that based on the equations. Depends upon the continuity equations and like Bernoulli's equations also. So if you look at this what we call inlet flow and through that inlet flow how it can be deviated or like what we call liquid or gas or water, how to passes to inlet to outlet flow. So while passing to the what we call center, that may be creating some what we call flow direction. So see the image, inlet flow and this is outlet flow. So it may be creating some vena contracta. So that also you can learn about what do you mean by what we call vena contracta. So that also will explain. And the main difference between orifice meter and the venturi meter, if you look at all venturi meter, the pressure loss. The pressure loss in venturi meter 10%, whereas orifice meter the pressure loss will be created to 50 to 60%. And the loss, first loss itself, we explained the coefficient of discharge. CD value of venturi meter is 0.98. So you should not go what do you call greater than 1. So it should be less than 1.98. But when you are going to do the calculations, it may reach 1.2, 1.3. That depends upon the instrumental error may be happening while taking the readings. Whereas orifice meter, it's around 0.6. And this is also while calculating, it may what we call average you may get for less than 1 or more than 1, but you should know how to take the readings. And also look at the turn down ratio of venturi meter. The turn down ratio means maximum flow, the ratio between maximum flow to the minimum flow. So through inlet pipe to outlet pipe, what is the maximum flow and the minimum flow we have to find out by using the turn down ratio For venturi meter is 10:1, while orifice meter is 5:1 or 3:1 also. And easily we can find out the cost of venturi meter is expensive, because if you look at image, more number of parts needed for venturi meter when compared to orifice meter. So this is a main key difference between orifice meter and venturi meter. But readings and what do you call it, finding the calculations, everything is similar. And also the description of this orifice meter, you know how to find out calculations and what are the unknown value you have to find out, and based on the calibration of orifice meter means determination of coefficient of discharge, that CV value. And also you should know like the difference between actual and theoretical discharge. So this is a what we call schematic of streamlines in an orifice meter during fluid flow. So inlet and outlet, upstream flow in and downstream flow out. So it has been creating for that what we call Vela contract or something. So that the depends upon the equations already informed. It may be applicable for continuity equation and also like what Bernoulli's equations. Through this diagram, what do you call? It has been included differential manometer. You have to take left side reading and right side reading and finding out time taken and also calculate the coefficient of discharge. This is another diagram. So easily you can learn about what we call high pressure connection and low pressure connections, leaving one section to another, diameter D1 and D2. And this like procedure, yeah.
Sir, sorry to interrupt, sir. I think slide is not changing.
Slide is not changing. Yeah.
Yes, sir.
Now?
It's in procedure slide, sir. Correct.
Yeah, now previous slide. Previous slide. This
Sir,
are.
no, sir. We didn't see that, sir.
This is okay. I think this is.
Now it's okay, sir. It's in procedure slide, sir.
Only procedure you want.
Sir, no,
Yeah.
sir. We didn't see that previous slide, sir.
Beginning. Yeah, fine. So this one, yeah. Now it's okay. Now it's visible. Venturi meter has orifice meter. Can anyone respond?
Sir?
Yeah, is it visible?
Sir, procedure slide is visible now, sir.
You want procedure slide?
Sir, no, sir. Now.
Sir.
Yeah.
Earlier, that diagram, the venturi meter diagram was shown, and in between the diagram and the procedure, no slides were moving.
Now you can see, but in my system is moving on the slide.
Okay, sir. Now we can see only procedure slide, sir. After that, we came here, sir.
So this is procedure before the slide. So now you can see in my laptop it's moving one by one.
Okay, sir.
Just a minute. I'll put minimize the video. Now you can see. It's
Yes,
moving
sir.
one by one.
Yeah, now it is moving, sir.
Okay, I close that full view. I put it Windows view. Yeah, fine. Just I increase slightly. Now you can see. Yeah. So this is already we discussed about what is the difference between venturi meter and orifice meter, and this is like orifice diagram. Consists of a thin plate and a bone. So the fluid direct from inlet to outlet, and this is a main difference between orifice meter and venturi meter. Okay, the pressure loss with respect to coefficient of discharge, venturi meter is 0.98 and orifice meter is 0.6, and already I told the turn down ratio. So that means the difference between maximum flow and the minimum flow. So as venturi meter is 10:1, while orifice meter is 5:1. And also based on the diagram, we can easily find out the cost of venturi meter is expensive, because so many parts are available for orifice venturi meter when compared to orifice meter. Then this is a description, and this is a similar description about venturi meter. And also you're going to learn about this orifice meter. You have to find out coefficient of discharge and also what they call actual discharge, how to calculate theoretical discharge and velocity, those things. And this is schematic what you call diagram of orifice meter, fluid flow upstream to downstream, inlet 1 and inlet 2. That also we explained in terms of what you call working principle related to continuity equations and Bernoulli's equations. So everything you are going to learn theory part, but just I want to give some idea what is the uses and application of those things. And this like before that just I want to show one videos, that videos we captured from fluid mechanics lab. So through that video you can able to understand how to take the readings like venturi meter, orifice meter and torsi friction also. So you see the video, then after what they call, we can start the procedure, then I will give the reading. You can calculate step by step what you did in the venturi meter reading. Is it clear? Till now any doubts? Till now any doubts? Is it clear? Any queries? Students?
No, sir.
Yeah. So now I want to show videos. So just I'm going to share this video. Can you able to see this video? Yes? Students, already shared videos.
So we can't see, sir.
Now you can see.
No, sir.
One second, one second. Now?
No, sir.
Yeah.
No.
Wait. So now can able to see presentation, and I'm sharing this video also. Just a minute. So I'm sharing the screen. Yes.
Yes, sir.
Yeah. So just look at this instrument which is used for what I call fluid mechanics orifice meter. So whatever I explained, what venturi meter. So this is manometer reading. This is manometer reading. So through that manometer reading, you are going to take part left side and right side of the reading. Okay, left side and right side of the reading. So like what do you call, you know the basic principle of this procedure. So any instrument like venturi meter or orifice meter or torsi friction, before switching on the pump, definitely we need to ensure that priming. You should know what I mean by priming, and also proper closer valve, all valve, gate valve and other valves. And we should select the what you call proper orifice meter. Okay, different types of orifice meter which can be used for different purpose. So select the given orifice meter for which calibration is done, and also what we need to find out this manometer limb like left side and right side. And third step, open the main valve fully. Okay, if open the main valve, what will happen? The what you call the maximum difference, I mean pressure difference between the limbs of manometer will be identified. Okay, open the main valve fully. So with respect to selected orifice meter, and observe the maximum pressure difference between the limbs of manometer. That means left side and right side. And also water will flow to the what I call the tap fixer. And then initial position, note of the what I call time required to collect the volume of water for every 10 centimeter rise of water. Okay, every 10 centimeter rise of water, we need to take the what do you call, time taken. And also the fifth position, reduce the flow and note on the new pressure difference and also time required to collect volume of water. Again, 10 centimeter height of the water in the tank. Repeat the procedure for getting other similar data for difference of pressure with respect to time and also what we call other parameters. So use that same procedure. You have to take like 2 trial, 3 trial or 4 trial. So just I want to show the full, just listen here. So this is manometer reading. So once open the valve, so you have to note on left side reading, right side reading. And also you have to take what we call every 10 centimeter rise of water. What is the time required? So this is a trial 1. This is a trial 1 which is taken for this orifice meter. So by using what we call 10 centimeter rise of water, you can start anywhere. But you stop 10 centimeter rise of water, what is the time taken? So if you stop the watch, yeah, the 10 centimeter reach, you stop the watch. So what is the time taken in note? And also open the valve, water flows to the suction side and in some, again you have to the what we call take second set of readings. Any doubt from this figure, I mean videos? Any doubts? Any doubts? The similar thing you are going to take for readings, Venturi meter or the orifice meter also. Switch on the motor, open the valve, then water or liquid or gases through that what we call manometer passes through that port. So readings we have to take left side and right side, and also you have to take for every 10 centimeter rise of water times again. And open the what we call open the valve, so water will be goes to the sump, and again you have to take second set, third trial, fourth trial, fifth trial. So with respect to 5 or 4 average, you can note down the readings and do the calculations. And this tag, okay, this tag, this is a length of the tag. So just a minute. This is a length of the tag and this is a breadth of the tag. That is what I told, 40 centimeter and 30 centimeter. Correct? Yeah, length of the tag and this is a just. So this is a length of the tank and you have to calculate breadth of the tank and time taken H. So that is 10 centimeter means you have to convert centimeter to meter point 1. Any doubts?
No, sir.
Any doubt? Yeah. So every 10 centimeter rise of water, you need to take time so that you can calculate unknown values, manometric heat, and also heat loss, actual discharge, theoretical discharge, coefficient of discharge. This is breadth and this is length. Any doubts? No doubts?
No, sir.
Yeah.
Sir.
So, yeah, if you doubt, you can ask me. So, for this procedure. Can you able to see this presentation? Procedure is showing the slide. Yeah. So this is a procedure how to take what we call readings. The step by step is given. Switch off the pump, ensure it's priming. You need to what we call find out what you mean by priming. In the beginning class itself I told. So next class I will ask what I mean by priming and what I mean by Venturi-meter, Orifice meter, what is the difference, toxic friction factor, all those things. Just for recall all the terms, it may be useful for exam point of view. And also what we call select the given Orifice meter for which calibration is to be done. That depends upon the manometer links using the respective valve. Take valve, open the main valve, allow the water. So the water will flow to the left side and right side. You need to calculate both reading, and also you need to find out every 10 centimeter rise of water what is the time required. So that is what is given. Third procedure, open the main valve fully. You have to select which orifice meter and observe the maximum pressure difference. Both and the initial position, time required to collect volume of water for every 10 centimeter height of the water tank. And this is observation. From that the video, you should know like length of the collecting tank. So this is also constant for all Venturi meter, Orifice meter and toxic friction. So 40 centimeter means you have to convert meter. Okay, convert into meter, and breadth of collecting tank 20 centimeter convert into meter, and from this what we call L and B, you have to find out area of the tank. So 0.4 into 0.3. So what is the value you may get through meter square. So all the values you have to use by only meters. And diameter of the pipe for this diameter orifice meter diameter D1 20 mm. So 20 mm means you need to convert meter 0.02, and the orifice D2 10 mm. So convert meter. From this diameter D1 and D2, you are going to find out A1 and A2. And this is tabular column. So similar that Venturi meter and orifice meter, differential manometer reading, left side and right side, meter. If you take on centimeter, you have to convert meter. And time taken for every 10 centimeter rise of water. And manometric aid you are going to find out, F loss you are going to find out, actual discharge you are going to find out, theoretical discharge you are going to find out. Through actual and theoretical discharge, you are going to find out coefficient of discharge. Already I told the main difference here. You can see this one. Like for theoretically, in fluid mechanics theory, it may ask for that objective type coefficient of discharge for Venturi meter and orifice meter. So that things to be needed. 0.98 for Venturi meter and orifice meter 0.6. And next, you are going to find out this coefficient of discharge. Then we'll see this is a reading. You can note on the reading. Are you able to see the reading? Just I will maximize.
Yes, sir.
Yeah. So here everything is given meter, but the values I recorded through that physically. I mean fluid mechanics lab. Today morning I went and recorded the values, and you can note down the values. These are all values given centimeter, 8.5, 24.3, that is centimeter. But you need to convert centimeter into meter. Clear? 9.4, 23.3, all the values given here centimeter, but you need to convert meter. If you convert meter value, I mean the results will come accurate. And time taken for every 10 centimeter rise of water, 20, first trial, second trial 24, third trial 26, fourth trial is 28. So these are 4 trial readings which was recorded in centimeter. You have to convert into meter. One sample value also given here, how to convert centimeter into meter. Clear? Any questions? Any doubts? All the students note on this readings. Any doubts?
No, sir.
And directly we'll move on to the next slide. Already we discussed, just I minimize. Yes, calculation part. Okay. But the slide has been changing. Yes or no? Yeah. So this slide, you can look at calculations L1 R1. So that left side and right side of the reading. So whatever calculation done both venturimeter and torsive friction, similar calculations only you are going to find out here. And everywhere you have to mention the unit that is most important. Manometric HM, L minus R. So you can use highest value to lowest value and find out value should be positive, not for negative. Head loss, HF. So directly you can substitute HM into 12.6 unit and actual discharge through the pipe. Volume of water collected in the tap. L into B into H. H height of the collecting tank water every 10 centimeter. So L you know, L is the length and B is the breadth, and 10 centimeter also you need to convert 0.1 H divided by time taken. So each and every trial, you have to note on the time taken. That value you can substitute here and find out actual discharge meter cube per second. If one area you are going to put centimeter and another breadth you are going to use meter and H you are going to use centimeter, the values will be getting wrong. So all the values you have to convert centimeter into meter, and final results also you may get proper readings. And after calculation of actual discharge, you need to find out actual velocity through the pipe. Q actual, I mean this actual discharge divided by area A1. So A1 you know through D1 diameter. Yes or no? Diameter of the pipe D1, you can calculate A1. That value you can use here and find out the actual discharge, actual velocity, the theoretical discharge through the, and here, so here venturimeter not, Orifice meter. So instead of the venturimeter, you can use Orifice meter. So while uploading this experiment in Google Classroom, I will recorrect and upload it. And the formula you can use A1, A2, root 2 of G and H divided by root 2 square A1 square minus A2 square. So you need to find out meter cube per second. And this is also similar that venturimeter, computed coefficient of discharge, actual versus theoretical. You have to find out slope. You know how to draw a graph. Yes, the first two experiment, now you are familiar how to draw a graph, how to find out slope, and how to find out computed graph, results and graph results. Yes or no? Can anyone respond? Yes? Yes or no? Any doubts? No doubts?
No, sir.
Yeah. So this is like general instructions. Difference between, what is the value? Sorry for that. The results you have to calculate computation method and by graph method. And these are all the things, just definitions. And this also I will upload through that Google Classroom. You can find out what is the difference between all the terms. So terms, definitions, and difference, everything is needed during in semester. We may ask some questions also. And this is model graph. You know how to calculate the model graph. Okay. So any doubts? Any doubt? So next class will be continue for what I call performance test on turbine, pump, those things. Any doubts? So far, any doubts for third experiment? So far, any doubts for third experiment? Just you note on the readings. Okay, just note on the readings. So through this reading, you have to calculate all unknown values. Okay, all unknown values. So reading, can you note on the readings? So while uploading in Google Classroom, I will not mention any reading. If you want, note on the readings. All of you noted the readings? Yes. Shall I go to next slide? Yes or no?
Yes, sir.
Yeah. So just note down the reading. So after this, like again, I'm going to show that video. Just listen that video. Then after that, I will use what I call Orifice and Venturimeter. One virtual lab will be there. That also I will explain for understanding. That reading just you have to take and put it extra things in your record itself. So again I want to show this video. Just listen here. Yes. Everyone seeing this video? I shared. Richard?
Yes, sir.
Yeah. So shall I increase the this is a length and this is a breadth. See here, close the ball and take the every 10 centimeter, 15 centimeter, whatever things. So take the time taken, and after taking time taken, again open the valves. So water will flow to the sump, and repeat the procedure. If you want trial 1, trial 2, trial 3, trial 4, trial 5, whatever things. If you take average 4, so you need to calculate best results. We have to easily identify. Shall I stop this video? Any doubts? Shall I close this video? Yes.
Yes, sir, you can.
Yeah, sure. Thank you. And now, just last step. Through that video, you have to take that reading and calculate unknown value. And also, virtual lab. Just I want to share something. Yes. Just a minute. See this how to take readings. So go to Google. So through Google type Venturimeter and just you type Orifice meter virtual lab. See if you type Venturimeter Orifice meter virtual lab, the first one you can see Orifice meter and Venturimeter virtual lab. Here everyone visible this Orifice meter and Venturimeter? Yes, that simulation part. Yes or no? Students, can you respond me?
Yes, sir, we can.
Yeah, thank you. Just I minimize this one. and I can show like, so this is a experimental setup. You can see there, both experiment we can do at a time, Orifice meter and Venturi meter. If you look at this, click on this procedure, so we can able to see second screen. These 15 procedure will be there. Yes or no? Procedure. Yes.
Yes, sir.
Yeah. So you can read these procedure and do the what do you call reading taking. For simulation part, the first step, it's clearly given here. When we are going to take the readings, just a minute. When you are going to take the Orifice meter or Venturi meter reading, what do you call that procedure, you have to follow it. Okay. If you look at Venturi meter, just I minimize. If you look at this, so sorry. If you look at this, what do you call virtual lab, the step is given here. What we need to ensure that which things we need to stop, either Orifice meter or Venturi meter. So I want to set Orifice meter, and also here you are going to find out flow rate. So in terms of flow rate, 100%, 75, 50, 25. Okay, so first I want to set flow rate 100%, and I want to select Orifice. If we select Orifice and stop the button, the water will flow to directly Orifice meter, not for downwards Venturi meter. If you look at the flow, it's directly move on to the Orifice meter, and while reaching that manometer reading, you have to take for left side and right side of the reading, and also every 10 centimeter rise of water. So just wait here. So once it reaches the water to the tank, it will not on see here. It's showing that the repeated procedure. Just look at here. So you close the valve button. So you close the valve button and click on the stopwatch every 10 centimeter rise of water. If reach every 10 centimeter rise of water, switch off the stop timer. Exactly, you need to switch off the stop timer. So if stop timer, again it's showing that 10 centimeter mark is reached, and you can see the what we call pressure difference in terms of what we call left side and right side. So left side and right side directly given the reading 89. What is the time required every 10 centimeter rise of water? This is for 100% flow of water. Just for taking virtual lab reading, just put it these two things in your record. This is not required for do the calculations. What we showed that slide time table readings and time taken, those readings you have to calculate for coefficient of discharge. But these things you have to try it and put it Orifice meter, pressure difference, time required. This is 100% flow rate. Again, you can reset and select the flow rate 75 and start and then Orifice. You need to take the values, and every 10 centimeter rise of water, it will be recorded for 70%. What is the pressure difference? What is the time required? Clear? Any doubts?
No, sir.
Yeah. So this also you can try through virtual lab, but the virtual lab just you take these two tabular column and you have to find out 100% flow rate, 75% flow rate, 50% flow rate, and 25% flow rate. And what is the time required? For this, no need to calculate, because here, just I want to show this specification and all, it will be complicated. Supply 5 diameter, Orifice inlet diameter, Orifice through diameter, measuring tank, L into B into H. Here values will be different. So no need to calculate coefficient of discharge, those things. Just you calculate I mean, you have to choose flow rate, different four set of flow rate, and find out what is the time taken and what is the pressure difference. So this is one thing, and the main thing, through the physical video recording, already we given the readings. Those readings you have to find out all unknown values by using graph and also by using computation method. Clear? Clear?
Yes, sir.
So if you have any doubt, you can ask me so we can clarify the doubt. And if you are free means you can start now. It's a third experiment. You can do the calculations and post it in Google Classroom before the next week. So we will evaluate first three experiments and will be awarded out of 30 marks how much marks you got it. Any questions? Any doubts?
No, sir.
Yeah. So all of you open the system what I told, and before that, just you can type this lab. I mean virtual lab or what you call four flow rate. Okay, four set of flow rate. You have to try it. Meanwhile, I will convert that third experiment presentation into PDF and I will upload to Google Classroom. You can download and start for writing. Is it okay for all? Yes.
Yes.
Yes, sir.
Yeah.
Thank
You
you.
can start any doubt is there. So now itself you can try go to Google and type Orifice and M.SURESH which will have one link will be there and you read the procedure. So whatever I explained the procedure, the same procedure here also will be followed. You have to do it only Orifice meter and take four set of flow rate. So you take four set of flow rate and time taken, the difference between pressure. And meanwhile, I'll upload all the documents in Google Classroom. So you need to do one page. This virtual lab, I took different flow rate, 100, 75, 50, 25. What is the time required and what is the pressure difference? Thank you. Thank you.
Thank you, sir. Thank you.
Yeah, yeah. You
Thank
can
you, sir.
start. Yeah, you can start. I will convert the third experiment PDF and I will send it to Google Classroom. Sure. If you have any doubt, you can call me through WhatsApp or mobile and also what I call it. Any more? So we will clarify the doubts also. student? Can you hear me? Yes.
Yes, sir.
See, just now I cross-verified through Google Classroom. First two experiments, only 4 students have been completed and uploaded. Other 39 students, you have to try to upload and get the marks, what I call out of 30, otherwise it may be reduced. And third experiment, I have uploaded PDF document. You can check and download those things and do the, what I call, calculations, whatever unknown values. It's very pathetic situation because 1 month has over, till now only 4 students has been uploaded out of 43. So just try to upload your documents on time. Is it clear?
Yes, sir.
Please try to upload everything we given data. Just you are going to copy and do the calculations, any one trial, and also take virtual lab reading, put it and upload it, convert PDF and upload it. If you have any trouble for or problem for uploading or writing those things, inform to us. There is no problem will be happen. Even LKG students, if we have to give all those things, they will copy and upload it. That work only you are going to do it. Just copy and upload and do the model calculations. You have calculated and convert centimeter to meter and find out all the unknown values and do it. Is there any complicated for that? I am asking everyone. Is there any complicated? Is there any problem for doing the calculations? Just open your mouth, say something, so that I can able to understand. So whatever we taught almost reach to the what we call all the students. Any doubts?
No, sir.
Then you
No,
have
sir.
to do it just 5 seconds or 5 minutes. If you take one experiment, you have to do it 5 minutes or 5 seconds. That depends upon your presentation time only. You have to write out neatly, draw a graph, or else maximum you take 10 minutes. One experiment 10 minutes only. For calculations, you are going to do it one set of calculation. Either trial 1, 2, 3, 4, any one. And which one lab reading you are taking and copy paste. And again I am repeating, don't copy with other records. Easily I will find out and you may got very less mark if you do or copying to someone. Right? Yes. Everything is clear?
Yes, sir. It's clear.
Yeah. So I am expecting before this internal exam, you have to upload all 3 experiments. Those who are joined late, ask them what they call. Those are present the students how to write and how to take readings. The similar Orifice meter reading video, it may useful for Venturi meter and toxic friction factor also. The same, but working principle will be different. That's all. Ask them all 43 students, you have to assign that work and upload it and get the good marks. So before that, during this what we call exam time, we will evaluate and enter your marks in EduSearch. Right, my part?
Yes, sir.
Yeah. So before starting off your internal, we will evaluate your first 3 experiments and we can enter through EduSearch. So before that, you can proceed and we need presentation everything. Thank you. So just stay online and you can start all the records step by step. You can check Google Classroom. I have uploaded third experiment. Download and take paper and start all those things. And you can upload it. Then later I can take attendance. If you have any doubt, you can ask. I'm in online only. If you have any doubt, you ask me. I will answer whatever doubt if you want. Okay? Richard?
Yes, sir.
Yeah.
Yes, sir.
Don't leave the meeting because I want to take attendance after 3:40 or 3:30 or 3:35. So any doubts?
No, sir.
Okay, okay. See, don't leave the meeting. I will take attendance. Don't leave the meetings. Is it clear?
Yes, sir.
Yeah, don't leave the meetings. Those who have joined late, ask them already those who have completed first two experiments, including all three experiments, you have to upload it in Google Classroom before what do you call this midterm test. ULK 20 ME 1001. Karen Leander. Answer or attendance. ULK 20 ME 1001. URK 20 ME 1001.
Sir. Yes, sir.
URK 20 ME 1002.
Yes, sir.
1003.
Present, sir.
1004.
Present, sir.
5.
Present, sir.
7.
Present, sir.
8.
Present, sir.
9.
Present, sir.
10. 10. 11.
Present, sir.
12. 12. 13.
Present, sir.
14. 14. 15.
Present, sir.
16.
Present, sir.
17.
Present, sir.
18.
Present, sir.
19.
Present, sir.
20.
Present, sir.
21.
Present, sir.
22.
Present, sir.
23. 23. Sriram. 24.
Present, sir.
25.
Present, sir.
26. 27.
Present, sir.
28.
Present, sir.
29.
Present, sir.
31. 31. Mohammed. 32. 32. Alex. 33.
Present, sir.
35.
Present, sir.
38.
Present, sir.
39.
Present, sir.
Sir, 31 present, sir.
Yes?
Sir, 31 present, sir.
Okay.
12%, sir. Sir, 42.
Wait. Once I complete, I will recall. Just stay on the line. 41,
Present, sir.
42,
Present, sir.
44,
Present, sir.
46,
Present, sir.
47, Midun Chakravarti, Midun 48,
Yes, sir.
50,
Present, sir.
UTK 20 ME 1001.
Yes, sir.
Yeah. So just number 10 is there. Number 10, 12,
Present, sir.
14, Vishnu Sam, 23, Sriram, 32, Alex, 47, Midun Chakravarti, the same register number. I'll post it. Don't leave the meeting. I'll post it here. These students are absent for today lab. 10, 14, 23, 32, 47. Anybody is there? Anybody?
23 present,
Who's 23? Sriram?
sir.
Other guy, anybody is there? Just check it. 47, 32, 14, 10.
Sir, 10%, sir.
10.
Yes, sir, 10%.
Where? How many times I call?
I'm facing network issues, sir. I can't unable to connect, sir.
14. 14. Vishnu Sai. 32. Alex. Then 47. Nidhu Chakravarti. Only 3 students are absent. Just I'll post it. These 3 numbers are absent for today class. Just check it. The first 3 experiments, any doubt is there? No doubts?
No doubt, sir.
Yeah, you can leave the meeting and you can stop and upload it on time. You may get marks.
All right, sir. Thank you.
Thank you, sir.
Thank you, thank you, thank you all.
Thank you. Thank you.
Thank you, thank you,
Thank you, sir.
thank you, thank you.